Hello, everybody. Thank you for joining us. Me and Alon are here to start the next session, which is going to be about orchestrating in the serverless world. And the session will be delivered by MVP and MRD, Daron Yöndem. So, Daron, the stage is yours.
Hello. Okay. How are you guys doing? I hope you like the conference so far. So in this session, let me switch gears here. So here's our slide deck that we're going to use. So our topic for today is function orchestration in the world of serverless. Our focus will be Azure. But the products that we will talk will be Azure based, but some of them, to be honest, actually all of them recently with the recent changes, all of these products that we're going to talk about are stuff that you can move outside Azure as well, on-prem, or even maybe in some other cloud vendors that we don't want to talk about a lot at least right now. So, but you're not going to be totally stuck with Azure if that's what your perspective is. So let's get into it. So when we talk about serverless and functions, and especially when we go into orchestrating functions, obviously we are assuming you have multiple functions. So this session, the content that I have here assumes that you did build a couple of functions yourself. You did get your toe into the water, and you know a little bit about the topic. And this is about the next step. What happens if I have multiple functions? What happens if I have hundreds of functions? Right? How I'm gonna make sure these are working in a proper manner. How do I communicate between functions, and how do I orchestrate all of these functions that I have? And when you look at that from an Azure perspective, the two products that shine are Azure Logic Apps and Azure Durable Functions, and they too serve totally different needs. Or let me reverse that. They serve totally different audiences, fulfilling the same need. They help us orchestrate our functions that we have. One of them is, the Logic Apps, as I got some notes on the slides as well for myself and for you. So Azure Logic Apps are for people who like to have user interfaces, who need user interfaces, and who prefer using user interfaces to define what we're going to do at the end of the day is defining a workflow, right? We will start from one function to jump into another, or manage the state of another function, and sometimes it's going to be sequential. Sometimes we want to do run functions in parallel. Sometimes we want to do both in a single flow, and you need a tool to be able to design that workflow. And Azure Logic Apps gives you a UI on the Azure portal where you can design the flow. And that means you don't need to know coding. So this is pretty much a no-code experience. And it's beautiful because you might want to, even if you are a developer and you are really good with development, right, and you don't have any problems with coding, the question is, who are you going to deliver the solution, right? Do you want to provide some flexibility to third parties, for example, to be able to change the flow, or some of the decisions within the flow without really getting into the code? So in that case, maybe you might want to prefer a UI to do that. The other advantage with Logic Apps, and this slide deck is a 60-minute slide deck usually, so I will go a little bit fast. So right now I'm jumping into a couple of slides ahead, but that's okay. So one of the other advantages of Logic Apps is the beauty of their connectors. So you might argue, hey, what has it to do with function orchestration? But at the end of the day, it's just an advantage. If you are building a flow that touches, third-party endpoints, if you're building a flow that, will send an email through SendGrid, or maybe, talk to a third-party payment provider or anything like that, or will do some operations on an Office 365 calendar, right? The advantage of doing all that with the logic apps is the fact that it has built-in connectors, and you don't have to write all that, code to implement all these APIs that they have, authenticate with them, and so on and so forth. With that, obviously, our logic apps compared to a full, hands-on, I'm going to do this whole thing myself approach, logic apps is a little bit expensive. But, it is what you get, right? It solves a lot of problems for you pretty fast. So someone has to pay for it. The other option is the Azure Durable Functions. Durable Functions is a beautiful thing. It's one of my recent loves. It's something, there is this, if you have been in development for a long time, sometimes something comes up and you're like, wow, that's exactly, I guess the last time I had this feeling, I'm not 100% sure about this, so let me go back. But, right now, the next thing that I feel like I remember that I felt the same way was language integrated query in C#. I was like, okay, this is cool. And durable functions kind of created the same feeling. And I was like, wow, this simplifies a lot of stuff that I'm doing, and this is just great. So, and long story short, it helps us orchestrate our functions and define those flows with C# code. I mean, in this case, I'm going to be using C#. I'm not 100% up to date on it, but I know there's a JavaScript and Python initiative about durable functions as well. I mean, if you're interested, definitely go and do some research. It might be GA or not. I'm not following, those durable function versions for those languages, so I don't have up-to-date information, but I know that there is something going on. I'm seeing it spontaneously on my Twitter feed. Like there is willingness on the Microsoft's end to move durable functions to other languages that are supported as part of the Azure Functions runtime. But for now, within the scope of this session, I will focus on C# because that's what I know. Okay, let's get into that. So durable functions. What durable functions do is they help us, run stateful functions. That's an interesting one, right? Stateful functions mean the state management of the function will be managed by the durable functions runtime, which means someone will, create checkpoints, save the state somewhere. In this case, it's going to be Azure Storage, and restart the function if it needs to be, and be able to resume the function when it's needed. So that's kind of pretty beautiful, right? If you and as a sales pitch, it's a beautiful thing. But you will see it's crazy easy to do all these stuff, and being able to manage the state and have stateful functions helps creating this workflows, because a workflow is all about the states and being able to manage and go through these states, right? So what we do is we create those orchestrator functions. Orchestrator functions are responsible of orchestrating all the functions. We write our orchestration code within the orchestrator function, and then we got a bunch of activity functions. We call those activity functions, at least from the perspective of durable functions, is what they're called. So there are activity functions who do the work, and then the orchestrator function orchestrates when a particular activity function should start and how they should be monitored, and so on and so forth. And should we go through this? Yeah. Workflows. Yeah, we're defining our workflows in code, no JSON schema or anything, no designer at all. You can call, other activity functions synchronously or asynchronously. The output from all these called functions will be saved in the storage for you, so that the next time you hit that, when you're resuming a function, you will get the output from the storage. So you might think right now, like, hey, that storage, the Azure storage in that case might be a bottleneck. There are workarounds about that, and yes, it might be a bottleneck if you go massive scale. There are some initiatives to have, I know it's right now the underlying storage mechanism is pluggable, but as far as I know, there isn't any GA production quality storage providers developed yet. I heard an initiative about Redis, but I'm not sure where that is. So right now, if you start with it, it's Azure Storage, and sometimes we do things like, if you go massive scale, we do things like partitioning across multiple Azure Storage accounts through the use of orchestrators. What else do we have? They automatically checkpoint your progress. Let's see that. I mean, this is the first example. This is a pretty easy one. So we got sequential logic, right? We got one function running the other one and the other one. Usually what we do, if we had to do something like this, what you do is you put some kind of a queue between the functions, right? I mean, the first function or worker, if you're that old and you know about Azure Cloud Services and worker roles, if you had multiple workers or whatever you call them, then one of them does the job and then puts a job into the queue, and the other one listens to the queue, gets the job from the queue, does the processing, and hands it over to another queue, and so on and so forth. And this helps us independently scale every worker, right? I mean, function 2 can independently scale because its scalability, the requirements defined on the amount of jobs on the Q1. Let's say the first Q1 does that. In this diagram is Q1. So that's how we would design it, and we can do this. There's no problem with this, but it's a lot of it's a lot of work, right? There's a lot of code that needs to be written. There's a lot of error handling you have to do. So it's maybe simple, but it's not easy, right? So how do we do that? I got a Visual Studio instance here. I don't have any code in it right now. I wanted to start from scratch. So what I'm going to do here is, and before I do that, let me see if I have my, I always forget this one. Yeah, there we go. So File, New Project. We're going to create an Azure Function project from scratch. So I got Azure Function here, next, and the location isn't important. Just create the project for me. We are going to get an empty project for now. I don't want anything in there. Create it. The reason I'm starting from scratch is you're going to see that there's a template which spins out a lot of code, sample code, that's going to help me do the demo. And if you want to go through the demo yourself, it's really very easy. I just want to make sure you can see all that. So let me zoom in here. As you can see, there is no function in this app right now. Oops, sorry about that. There we go. Okay, no functions at all. It's totally empty. I'm going to right click on this one and say add new Azure function. Perfect. Here we are. So Azure function 1 CS. I'm not going to change the name and say add. And here we get another list of templates that we can use. And in this case, I will pick this durable function orchestration option. And this is going to prep our function app and add the NuGet packages needed and spin up the code that we can use for our demo. I'm going to click add. Let's zoom out. Waiting for a moment. Okay, here we go. Great. So we got one function, 1 CS file in our project. This isn't the way I would ideally, design a function app, because in this case we got 3 functions in the same physical file. Usually I separate those, but whatever it is, we got the code in here. So let's look into that. So the first thing to understand here, the important thing to understand here is this one. This is what the work is, right? This is what the function is supposed to do. I mean, we have a single function that says say hello. It gets a string as a parameter and returns hello world, essentially, right? And that's it. This is the function that does the work. This is the function where you're gonna do whatever you want, right? Create a PDF, store some file, process some JSON, whatever you want to do. So this is the activity function. We call those activity functions. We flag those with activity trigger. Because we're not going to start these functions, but someone else will. Durable functions runtime will. So what else do we have here? And here down here we got another function. This is for the purposes of testing. This is an HTTP trigger function, as you can see. We're going to use this function to create a new orchestrator instance. So we got to kick the tires, right? So we got anonymous access, get for post. What else do we have here? HTTP request, durable client. Oh, that's an interesting one. This one comes from durable functions runtime as well. We get orchestration client, which helps us talk to the orchestration runtime. We got a durable client. Cool. So here's what the HTTP function does. It actually creates a new instance of function 1. Okay, what is function 1? It's not our activity function, because our activity function, the one that's going to do the work, is function 1 hello. It's something else. This is actually our orchestrator. We will look into that. It's on the top of this file. We will look into that a moment later. But it looks like we are calling the durable client, right? and telling the Drupal client to start an instance of function 1, which is the name of our orchestrator. Okay, you can start orchestrators whenever you want. In this case, it's just for the sake of the demo. It is starting through an HTTP trigger, right? You can do whatever you want to spin up multiple instances of orchestrators. So when we're starting a new instance of the orchestrator, we're not passing any data into it. We could have sent some data to it as well, but in this case, no data. That's why this parameter is null. And when we initialize it, we get an instance ID back. But keep in mind that this is, even though this is awaited, this is start name async. So this is the start of the orchestrator. This doesn't mean that the orchestrator has fully executed and done. This is just, we were able to initialize, we were able to start. The initialization of the orchestrator is complete. That's it. And we got an instance ID to that. And finally, this HTTP function returns back a status report. The status report, we get it from, again, Drupal client. This is a method we use from Drupal client, part of the functions runtime, Drupal functions runtime. And we give it the response where the stream will be put it into, and then we give the instance ID of the orchestrator. So we are simply saying the Drupal functions runtime that, create me a report for this instance ID, right, for this orchestrator instance. Create me a report and give it to me, and I will put it into the HTTP response. That's it. So what about the orchestrator? Let me scroll up. So here's the orchestrator. The name is function 1. This is where all fun begins. So if you look at the signature of this method, we got orchestration trigger, cool, which is an orchestration context. That's nice. It looks like I'm getting some context to be able to talk to the Drupal functions runtime. Then I'm creating a little integer, generic list of string, and then putting some variables into that, and then returning. So first question, what does this return mean? Because when I look down here, we started it, got an instance ID, and returned the report to the instance ID. I mean, no one waited for the orchestrator to finish. So where does this output go? This goes into the storage. And whenever we want, we can, query the Drupal functions runtime. We can give an instance ID of an orchestrator instance and say, what was the output for it? So I wouldn't use this as a means of storage of the results. So if you've got some huge stuff to save, most probably it's going to be an activity that you will call during your orchestrator at the end of the orchestrator before you return and finish your orchestration instance, right? So in this particular example, in the orchestrator instance, we got calls to the same activity trigger with 3 different parameters. So the way we are calling activity triggers is, again, through the context. Orchestration context. We give the function name. In this case, we are expecting a string back. That's why this generic type has string in it. And we are sending a string parameter into the activity trigger as well. And we are doing it 3 times sequentially, right? And we are waiting every time for the function to complete. So this function is running sequentially 3 times, and during the with this orchestration instance, orchestrator instance, right? So the important thing to keep in mind is that even though these functions, they are in the same physical C# file, when this thing is scaled, you never know if this function, the 3 instances of this function, even if they are sequential, and the orchestrator and the activity triggers, they can be running in different servers when you scale it. So having those in the same, C# file doesn't mean that they're running in the same, up domain or server or whatever you can imagine from an isolation level. They are running definitely in the same data center, but they are in different servers. So when we do this, we are actually calling a function on a different, so we might be calling on a function on a different server, and we are waiting for it. That's an interesting one, right? Because being able to do that so easily is beautiful. So let me put a debug point here and start this one up and see what happens. Okay, it looks like it's gonna take a moment. Come on. Wow, this isn't the first time I'm running this. that one is interesting. Oh, maybe there's an update to the function runtime, and that's what's messing up. Okay, very good. We got the HTTP endpoint. I will copy that. I will go to Fiddler and send a simple GET request to that. You know what? Let's put a debug point here as well at the beginning of our HTTP method and execute. Okay, there we go. So I'm going to hit F10 and F10. We got the instance ID. Cool. I will return back F10. Keep in mind that orchestrator's first, the debug pointer orchestrator instance didn't hit yet. So again, F10, and I'm going to hit F5. Okay, the orchestrator is starting. Meanwhile, when I go back to Fiddler, what we got back is, as a response, when we look into this, we got these URLs. So these URLs are URLs we can, talk back to the orchestration instance. We can send an event to the orchestration instance. We can, get a status, terminate an orchestration instance, and so on and so forth. So we can talk to the orchestration instance while it's alive. So when we are here, let me put a debug point on the activity as well. So now I will hit F10. Creating the generic list, F10. For the first time, I'm calling function one hello with Tokyo, F10. Okay, activity trigger did run. Let's look at the parameter. It says Tokyo, great. Let's move this here. Cool. F10, F10, and F10, and F10. Great. Orchestrator started from scratch. It looks like it. Okay, this is weird. So let's hit F10. So the outputs is null. There is no item in it, F10. Oh, was it going to run the same activity again? Let's hit F10 and see. No, it didn't. And the collection has already, no, I'm not, okay, there you go. Hello Tokyo is in the collection. So what did really happen? The Durable Functions runtime understood that this task has already been ran previously. It has the result for it, so it was able to resume. So resuming doesn't necessarily mean jumping into a particular code line, line number. It starts from scratch, but it is able to skip the tasks that it already ran in the past. So I'm not running the same activity over and over again, but I'm running the orchestrator from scratch because that's something I cannot, work around. But the good part is, again, when I hit F10 right now, see the activity trigger ran for Seattle this time. So if I keep hitting F10, you're going to see that this activity will be running sequentially 3 times. And, at the end, we will have the output. Let me hit F5 here. Remove this breakpoint, F5. And another F5. And there you go. We got 3 outputs with all the cities. So one thing that is important is making sure in the orchestrator you don't do any work except orchestrating, because the orchestrator will start from scratch. For example, in this case, the orchestrator did ran a total of 4 times to run 3 tasks. None of the tasks were repeated, but keep in mind that, for example, this initialization of the generic list of string, it did execute 4 times. It's not a huge deal as long as you don't do actual work in the orchestrator and you just do orchestration. So if you got some work that needs to be to be done, it definitely needs to be in an activity trigger so that its lifetime can be managed, its state can be restored. Perfect. So let's go to my slides. So this is one way of doing, orchestration. I got the code copy pasted in the slide deck. Another story is fan in, fan out. And that's a beautiful one as well. Instead of awaiting functions, you can actually await multiple tasks at once with task when all, right? You can use that and it's going to work beautifully. We're not going to do a demo on that one. So the other one is the eternal process. You can have an orchestrator running all the time. You don't necessarily have to, kill an orchestrator. An orchestrator can sleep and wait on an external event. And while it's sleeping, you're not going to pay any money for the compute because it's sleeping. Its state is stored. And until a particular event is triggered, your orchestrator will not come back to life. Right? So that's a beautiful thing. And while that happens, you can keep checking its status by these APIs that you saw on the report, output, on the JSON output that I showed you previously. From there, you can keep asking for the status of a particular orchestrator. Asking the status of an orchestrator doesn't necessarily wake it up. It just, queries the storage system about its latest state, and that's it. And again, you can have an external process kick that, or you can have a timeout process. Imagine you got a timeout task that you're waiting in your C# code. Make sure that you get the time from the durable orchestration context, not the machine time, because when you resume, you don't want to have a new time. You want to use the previous execution time that you already had. So there are a couple of tricks around that, but it just beautifully works. Okay. External events, here's a small example that I have here. So in this case, we got two things that we're waiting for. We are waiting for an external event. It's called SMS challenge response. The text challenge response is something you can send from those URLs that is shared on the report output. You can hit one of those HTTP endpoints and send custom data. In this case, we got two tasks on the screen. One of them is a timeout task with make sure you, this is important. So the timer is being created out of the context, which means the durable runtime is giving us this timer. It's managed by the durable runtime. So when I'm getting the current UTC datetime, I'm getting it not from the regular system APIs, but from the context, which means I'm asking, durable context, durable runtime to give me the current time. And then I'm using when any, which means either it's going to time out in 20 seconds or the external event will happen. And while I'm waiting for, the task when any happens, this orchestrator is sleeping and you're not paying for anything. Great. Logic apps. It's a short one. It's a really, really short one. And I will skip the demo for this one as well because it's just UI, right? So, it just helps managing on the UI everything, the flow and everything that we did so far with the code. You can do it with a logic app on the UI. Here's an example. In this case, I get an HTTP request. I get the HTTP request. I parse the JSON and initialize the variable. Yes, there is a box that you can drag and drop to initialize a variable in logic apps. And what I have here is you might notice that. Let me see. Can I zoom there? Okay. Food detect, this one. Oops. Okay. Food detect is an Azure function. It simply does an AI thing and detects if there's food in an image or not. But in this case, it only gets one image as an input and returns true or false, for example. But what I want to do is to make sure I can have an API that can get a list of images and iterate through it and return me only the images that have food in it, right? So I could do this with a function, but if I have a single function that can detect if there's a food in a single image, then why not creating a logic app to wrap it, get the list of images, parse the JSON, initialize a secondary variable to hold the images of the images that have food in it. Then I do iterate through my original collection. I call the food detect function again and again, and I got a condition in there that adds the particular image into the initialized variable that I have if there is food in it. So, and I do all that with UI in here. Let me see if I can. Oops, give me a second here. It looks like we still have a little bit of time, so it should be somewhere in here. There you go. This is the Azure portal. This is. Give me a second. Here we go. This is the logic app that I was talking about. I'm going to go into edit mode and show you what's in it. There you go. HTTP request, right? Post API, parse the JSON. Here is the schema that I have. Initialize a variable called food list. It's going to be an array. There's no initial value. And I'm going to loop through, the body that I got to this HTTP request. I will loop through it. I will call the food detect, sending the current item in the request body. And then I have a condition. If the response body contains no food, then there's no food. And it's not a beautifully designed API, to be honest. So in that case, it's going to be false, and I'm not going to do anything. If it's true, then I can append the output, the item in this for loop, right? We are in a for loop. The item in the for loop will be appended into this array called food list that I recently initialized. And finally, if I go down, you will see that I am serializing the food list collection that I created during this loop. and outputting it into a response. So this is a very, very simple example of what you can do. But I could have multiple functions in here, iterate through them, have different flows, conditions and all that. I could have tens of functions in this single logic app and orchestrate these functions and decide how the workflow will run, right? So, and you have this beautiful UI that you can use to, hand over to someone who is, going to maintain this thing. If you want to go into code, there is still code. There's a definition language that you can use, but it's not the whole. It's not really very helpful, to be honest, unless you want to check it into a source control or something. With that, let me share a couple of links. Here's the link to the workflow definition language that I just showed you. You might ask, hey, why did you share that link? Because sometimes, we're all developers right now. That's what I'm assuming. So sometimes if you get in trouble with the UI, it's nice to be able to get into the code and kind of fix something. So if you get into there, here's the definition language specs that you can use. The other thing is durable task framework and durable functions to get package. I wanted to share these because they're essentially a durable task framework is the thing that enables this whole thing. Essentially, through task, we are used to manage threads, right? From a high level, we're used to manage tasks instead of threads. That might be a better wording. And right now, a task doesn't necessarily represent a thread, but an Azure function that runs on a different server somewhere. So instead of managing the lifecycle or outsourcing the lifecycle management of a thread to TPL, we are outsourcing the lifecycle of a function to functions runtime, thanks to the durable task framework. So that's why I wanted to share the link to that one as well. With that, thank you. Here is the link to the slides if you're interested. I'm not sure if we have time to get questions. Do we? Let me see.
Nope, we don't have time for questions. Thank you very much, Daron. It was very enlightening. Thanks for joining us and contributing to our conference.
Yeah, thank you. And if you have any questions, feel free to hit me on Twitter as well. If something comes to your mind, I will be more than happy to help.
Cool. So you heard him. And again, thank you very much. The next talk we are going to have is by Noah Barkey about Git Force. So stay tuned, and we will meet again in